Okay, it's me again. So last night and earlier today, I was working on a series of videos on problem solving. So let's see, I think we've got 4 already. I've got one on just direct translation, and I'm absolutely being blinded. This room it gets a lot of sun this time of year. First video is on just basic direct translation. So how do we convert words to math? The second one was on direct translation with formulas. So we did 3 types of problems there. The first one was just like kind of recalling a formula that already exists, geometrically speaking. We did a problem where we were given a formula for a very, very specific situation, and we could use that formula to answer a question. And then the third type of problem is where the direct translation really comes into play. It's where we were given enough information about a particular situation where we could create our own formula and then use that formula to answer a question. From there, I went into problem solving with percent. And this is a little different than the percents you dealt with back in tier 1. I think it was unit 5. There, you do some pretty basic stuff. So what is 14% of 72? And then you just kind of work with either an equation or a proportion to solve that. You might have done some problem solving. You could have seen sales tax or discount, commission. You could have seen simple interest. You could have seen percent of increase, percent of decrease. The thing that's interesting there is you know what you're starting with, you know what you're applying your percent to. In these problems, you don't have the original value. You don't know what you're applying your percent to. You're applying your percent to some unknown value. And then we know kind of like what the end result is. So we use all of that information to find that original value. After that, I did just a basic problem solving with direct translation. And I showed you kind of what I think is my tried and true method for solving just basic direct translation problems where we're dealing with equations in one variable. We did 3 examples. We're going to keep moving on with that train of thought. This is kind of like problem solving with direct translation, but it's just a very specific type. So we're going to look at something called consecutive integers. I think these are super fun. They're generally not that hard for students. So let's take a look. Okay, so consecutive integers. First of all, consecutive means in a row. I could say you missed 3 consecutive Zoom meetings, and that would mean you missed 3 Zoom meetings in a row. And I wish some of you had only missed 3. Many of you have missed 3 a week. Anyway, what can we do? Integers are a set of numbers, no fractions, no decimals. They consist of all the whole numbers, 0, and then the negative counterparts. So that's what the set of integers look like. One thing that's really cool about these problems is if you're dealing with a consecutive integer problem, when you solve for x, x cannot be a fraction, x cannot be a decimal. If for some reason you get a decimal or a fraction, something went wrong. So you can go back and look. So basically what we're going to be doing is we're going to be taking problems, and a sample problem could be something like this. The sum of 3 consecutive integers is 6. Find the integers. Now, what I have found in my many years teaching is that a lot of times students try to take shortcuts. Don't take shortcuts. When I teach these classes, I'm not concerned about necessarily what the answer is. Of course, I want the answer to be correct. Of course, if you don't get it correct, that's a problem. My bigger concern is how did you get the answer? And when you're in an algebra class, we're not interested in you playing tricks and you like moving numbers around and just playing around with them and luckily getting the answer. We're very concerned about you understanding the algebra behind how you got your answer. So if you all played with this long enough, you could probably figure out what this answer is without doing any algebra. I'm not impressed. I want to see your algebra. Okay, so keep that in mind as you work through this. Learn the algebra, because when you get to your curriculum level math course, they might not be too happy if you cheat and just give them answers without giving them algebra. Okay, so practice now. All right, so let's talk. There are basically 3 types of these problems that we could be dealing with. We could have just regular consecutive integers. Consecutive integers are a mix of even and odd integers. They have to be in a row, so something like 53, 54, 55, 56, and so on. Okay? The second type of consecutive integers could be consecutive odd integers. What's a little bit different here is all of the integers that we're going to look like have to be odd numbers. So we could have something like 29. We would skip 30 because 30 is even and we go to 31. We skip 32 and go to 33. We skip 34 and go to 35. Okay, so notice here, instead of incrementing by 1 like we did with just regular old consecutive integers, here we actually are incrementing by 2. We're skipping those even numbers that are in the middle. The third type of consecutive integer problems that you'll see at this point in your math class would be consecutive even integers. So let's say we had 80. Well, we don't want 81 because that's odd, so we would go to 82. We don't want 83, we go to 84. We don't want 85, we go to 86. Okay, so just like in the previous example, we're not incrementing by 1, we're incrementing by 2. So when you're dealing with just plain consecutive integers, a mix of even and odd, you're going to always increment by 1. And then when you're dealing with consecutive even or consecutive odd, notice you're incrementing by 2s. Whoops, I didn't mean to do that. Let's go there. All right, so let's look at the algebra behind consecutive integers. All right, so first up, let's look at just plain old consecutive integers. So remember the example that we had before. I think we did 53, 54, 55, 56. Whoops. All right, we could start anywhere as long as we start with an integer and then increment by 1, we have consecutive integers. And so what we always want to do is assign the variable to the smallest integer. Let's just stick with this. You can technically apply the variable or assign the variable to any of the integers, but let's always stick with the smallest, okay? Okay, so let's say 53 is x. Well, the next integer in line is going to be 1 more than x. So x plus 1. And then the next integer is going to be 1 more than that. So it's going to be the original x plus 1 again, x plus 2, and then x plus 3, x plus 4, and so on. So if x was 53, I would get 53, 53 plus 1, or 54, 53 plus 2, or 55, 53 plus 3, or 56, 53 plus 4, 57. I could keep going, but you can see here that this algebra will absolutely give you a list of integers that are just consecutive in a row, no skipping evens or odds. All right, let's look at the algebra behind consecutive odd integers. All right, I think I used 19. Did I use 19 or 29? I think maybe it was 29. Let's see. So I think I did 29, 31, 33, 35, and so on. So just like before, we're going to assign the variable to the smallest integer. All right, so in that case, we would start with x. That's going to be our smallest integer. And notice, to go from 29 to 31, I have to skip 30. So I basically go from 29, I add 2, and I get 31. I need to add 2 more to get to 33. I need to add 2 more to get to 35. I could keep going. So here, because we're incrementing by 2s, our algebra, instead of incrementing by 1 like we did on the previous slide, we're going to increment by 2. Got a little goof here. Let me fix it. I got away from myself there. It's nice when we're in class because you all could like shout out and correct my little goof, but here I always find them after the fact. Okay, so let's play. Let's say x is 29. Well, 29, which is x, plus 2 is 31. 29 plus 4 is 33. 29 plus 6 is 35. 29 plus 8 is 37. And we could keep going, but notice 29, 31, 35, or whoops, 33, 35, 37. We have a series of odd integers that are in a row. So consecutive odd integers. All right. Let's check to see what the algebra looks like when we have consecutive even integers. So algebra for consecutive even integers. All right. So I honestly don't remember what example I used originally, 80. So we started with 80. We skip 81, we go to 82. We skip all those odds, so the next even would be 84, and then 86, and so on. Just like in the previous examples, we're going to assign the variable to the smallest integer. All right, so the first integer would be plain old x. And just like with even, or just like with consecutive odd integers, for even integers, we're having to add 2. To go from 80 to 82, I add 2. To go from 82 to 84, I add 2 more. To go from 84 to 86, I add 2 more. So my next integer would be x plus 2. And then I need 2 more than that, so I would get x plus 4, x plus 6, x plus 8, and so on. Okay, so let's play, let's practice. If x is 80, x plus 2 is 80 plus 2, or 82. X plus 4 is 80 plus 4, or 84. X plus 8, or x plus 6 rather, is 80 plus 6, or 86. X plus 8 is 80 plus 8, or 88. And we could keep going, we could keep following this pattern, but look at what we have. We have a series of even integers, and these integers are all in a row. What I want you to notice between consecutive odd integers and consecutive even integers is the algebra is the same. So I'm going to write it nice and big here. The algebra for consecutive even or odd integers is the same. So you really only have 2 things to learn here. You need to learn that with just regular consecutive integers where you have a nice mix of even and odd, you're always going to increment by 1. So assign the variable to the smallest integer and then increment by 1. For consecutive even or odd, they have the exact same algebra. So what we would do is start by assigning the variable to the smallest integer and then increment by 2's. Let's look at an example. So we're going to go back to that example I gave you at the very beginning. The sum of 3 consecutive integers is 6. Find the integers. Well, this, like I said earlier, is a problem where you don't have to do any math. You could just sit and think about it. But I want you to learn the direct translation. I want you to learn how to use the algebra, okay? So we would do just like we did in the last video where I did just problem solving with direct translation. We would start by listing this out in words. I want to take my first integer, my second integer, and my third integer. Whoops, that's a mess. My third integer, I want to add them, and it has to equal the sum of the 3 integers. So in this case, 6. Okay, so we've got it listed out in words. The first plus the second plus the third integer has to equal 6. Now we use direct translation to convert this to algebra. So what I've told you with consecutive integers is always let the smallest integer be x. It's so much easier if you do this. Why make life harder than it already is? So we're going to let the first integer be x. Now, we're dealing with just plain old consecutive integers. We're not worried about even. We're not worried about odd, just regular old consecutive integers. So the next integer is going to be one more than the last, and the third integer is going to be one more than the last. So the first integer is x, the second is x plus 1, the third is x plus 2. And just like in that previous video, we combine like terms vertically. I've got 3 x's, and then I've got 1 plus 2 is 3. This right here, this is the equation that we want to solve, and it's pretty much already simplified. So what we need to do is we need to isolate the term that contains the variable. So to do that, I want to subtract 3 from each side. 3's cancel on the right. I'm left with 6 minus 3 equals 3, and 3 equals 3x. So at this point, I want to undo the multiplication of 3 and x. So I would divide. Whoops, I'm going to go off the screen a little bit. Let me see if I can fix that. So I divide, the 3's on the right cancel. I am left with x equals 3 divided by 3, or 1. Now, check your work. This is something I talked about a good bit in the last video. You want to read the problem. Read it a few times if you have to. Start by writing out what your problem would be in words. Then use direct translation to convert to algebra. Create your equation and solve. Once you are done solving, you are not done. We need to answer the question being asked. Find the integers. Well, my first integer, x, is just 1. My second integer is x, or 1 plus 1. My third integer is x plus 2, or 1 plus 2. I need to make sure these 3 integers add up to the sum that we were given of 6. Well, 3 plus 2 is 5, plus 1 is 6. Everything checks out. So now I need to formally state my answer. Never assume that your reader is an actual mathematician, okay? So always pretend this is a presentation and you don't have mathematicians in the room. So I would say something very simple like the integers are 1, 2, and 3. And then you're done, all right? So let me play around and get another problem going. Okay, got another problem. Let's see here. So the sum, and in this, at this point in your work, when you do consecutive integer problems in Unit 9, they're all going to be like a sum, or you could potentially have a difference, but you're not going to have a product. A product would be tier 3, okay? So let's see, the sum of 4 consecutive odd integers is 104. Find the integers. Okay. Now, just for fun, I'm going to take my same method for solving these problems, but I'm going to do it horizontally. So some of you can just see if you prefer the horizontal setup compared to the vertical setup that I generally use. Okay. So I am going to do this one. It's the same exact method. It's just horizontal versus vertical. So you can kind of see the setup and choose the one you like the best. So we're dealing with a sum. That means we're adding. We are adding 4 consecutive odd is important. So we're going to get the sum of 4 consecutive odd integers, and that sum has to be 104. So I've got my first integer. I'm going to add it to my second integer. I'm going to add that to my third and my fourth integers, and that has to all equal 104. Okay. So if you like this horizontal setup better than the vertical one, knock yourself out. You do whatever is going to be the best for you. Okay. Now, just like the previous example, we're going to let the first integer be x. And now we're dealing with consecutive integers that are odd. So we always have to skip an even. So instead of incrementing by 1s here, we're going to increment by 2s. Always increment by 2s in the odd and even examples. So my second integer is x plus 2. My third integer is going to be 2 more than that, so x plus 4. My fourth integer is going to be 2 more than the previous, which would be x plus 6, and that still equals 104. okay? So then we combine like terms. I've got 1, 2, 3, 4 x's. And then I've got 2 plus 4, which is 6, plus 6 more is 12. And that equals 104, okay? So what we want to do now is we want to isolate the term that contains the variable. So we want to isolate 4x. I do that by subtracting 12. The 12s cancel. I get 4x equals what? Let's see, 92. I would divide everything by 4. And let's see, 92 divided by 4 is 23. So we would say x equals 23. Now, you always want to check your work. So our first integer was 23. Our second integer was 23 plus 2. And then we had 23 plus 4. And then we had 23 plus 6. So let's see what these are. We get 23. 23 plus 2 is 25. 23 plus 4 is 27. 23 plus 6 is 29. So if you look here, we've got integers. They're all odd. They are, in fact, consecutive. Let's check to see what they add up to. So let's see, 23 plus 25 plus 27 plus 29 is 104. So everything checks out. Just don't forget, when you finish solving for x, you're not necessarily done. Go ahead and work out the problem, check your work like I did right here, okay? But then never, ever, ever, as long as you live, assume that your reader is a mathematician. So you want to write out your final answer to the word problem. Let me make that prettier. Hideous. All right, so we would say something like the integers are 23, 25, 27, and 29. And that's it. At that point, you would be done. All right. So this is the horizontal setup versus the vertical setup. It does not hurt my feelings if you use one versus the other, but always come up with a process that works for you, but always read the problem. And sometimes you have to read it 3 or 4 times. Okay. Come up with the problem in words, write it out in words. Okay. Then use direct translation to convert to algebra, create an equation, solve for x, and then go back and answer the question being asked. Here we were asked to find the integers. We double checked our work, and then we came over here and we wrote out our final answer. All right, let's do one more. Let's do an example of consecutive even. So let's see. Whoops, I messed up. All right, so let's say that we have the sum of 5 consecutive even integers is 250. Find the integers. Sorry, I'm writing a little small so I can fit everything in on this one screen. Okay, so again, we're dealing with a sum. We have this time 5 consecutive even integers, and their sum is 250. Okay, these are the important pieces of information that we need to do. So I'm going to take my first integer, I'm going to add it to my second, my third, my fourth, and my fifth integer. All right, when I add, I have to get a sum of 250. All right. Sorry, water break. Okay. So now we do the direct translation part. And just like with the previous examples, we want to make sure that the first integer is x. We're dealing with even integers, so that means we've got to skip all of those odds. So instead of incrementing by 1s, we're going to increment by 2s. So 2 more, and then 2 more than the previous, 2 more than the previous, 2 more than the previous. Okay. So let's see here. We've got, we need to combine like terms. So I've got 1, 2, 3, 4, 5 x's. All right. Let's see. 2 plus 4 is 8. 8 plus 6 is 14. And then 14 and 8 is, did I do that backwards? Oh, I did do that backwards. I thought, bless my heart. This is what's so great about these videos. You get to catch all my mistakes, and I'm not going to go back and redo the whole video for this. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. That's better. Sheesh, bless my heart. All right, so what we have right here is the equation that we want to solve. Please excuse my little goof. All right, here's our equation. We need to isolate the term that contains the variable, so I'm going to start by subtracting 20. I'm going to subtract it from both sides. The 20s on the right cancel. I'm left with 230 equals 5x. And 230 divided by 5 is 46. Now, right here, to get the x alone, we need to undo the multiplication of 5 and x. So we divide. Make sure you divide on both sides. The 5's here beside the x cancel. That leaves just a 1x. And then 230 divided by 5 is 46. So let's come over here and check our work. Now, our first integer we know is x, which is 46. Then we get 46 plus 2, or 48. Then we get 46 plus 4, or 50. Then we get 46 plus 6, which is 52. And then we get 46 plus 8, which is 54. Now, you want to double check all of these and make sure that these integers really do add up to 250. So let's see, 46 plus 48 plus 50 plus 52 plus 54 is 250. So everything checks out, okay? Now, you've worked out your problem, you've read it several times, you wrote it out in words, you used direct translation to convert it to algebra, you simplified and got yourself an equation, you solved your equation and you figured out the value of x, which we assigned to be the first integer. We then checked our work. Please don't forget to write out your final answer. You'd say something very simple like the integers are 46, 48, 50, 52, and 54. Again, don't ever assume that your reader is a mathematician. Always pretend you're doing a presentation for non-math people and write that answer out so it's clear for everyone. Okay? One more problem. The sum of two page numbers in a book. Well, let me rewrite that. I forgot a really, really, really important word. The sum of two consecutive page numbers in a book is 519. What are the page numbers? All right, so we've got two pages in a book. They're consecutive, okay? So they have two numbers that would be consecutive integers, and we want to find those page numbers. So I've got the first page, and then I've got the second page. And if I add up those page numbers, I have to get 519, all right? So in this particular case, we're going to let the first page be the first integer, or x. Now, if we're talking about two consecutive pages in a book, one page is going to be one more than the previous page. So the second page would have to be x plus 1. So then x plus x is 2x, and then I get plus 1. So my equation right here is 519 equals 2x plus 1. Let's subtract 1. 519 minus 1 is 518. That equals 2x. I need to undo the multiplication of 2 and x, so I divide. 2's cancel, and 518 divided by 2, I think most of you can probably get this one on your own, but let's do it anyway, is 259. Now, if the first page is 259, what does the next page have to be? Well, it has to be 260. Let's make sure those pages really do add up to 519. They do. So we would say something really simple like the page numbers are 259 and 260. And that's it. All right, so that's an example of kind of a more real world problem. A lot of times you'll see problems for consecutive integers like three houses on the same side of the street have house numbers that are consecutive odd integers. If the sum of the house numbers is blah, what are the individual house numbers? You can do the same thing with rooms in a hotel, pages in a book are common. There's one problem that I've seen where a piece of wood is being split up to where each cut is 1 inch more than the previous. That would be consecutive integers. Overall, I don't think consecutive integers are the hardest problems out there. They're as far as direct translation and problem solving, I think there's some of the actually some of the easier ones. But really, don't skip the algebra. A lot of these you can play around, fiddle around with the numbers, do some trial and error, and you can figure out the answer. None of your math instructors are going to be impressed by that. Okay, if you're in a class where we're teaching you algebra, we're going to be very impressed with you showing your work, showing us those algebraic steps, creating that equation by using direct translation, and then solving the equation. Okay, so don't take shortcuts. Okay, really learn the process. And these are easy problems to learn the process because they're really not hard and they're easy to check. Okay, so you've now got 5 videos in a problem solving series. I'm going to do another one in a minute on break even. After that, I'll do some direct translation with geometry. I still haven't had a chance to look in EdReady to see how much they cover with uniform motion, but I might do uniform motion. A few things that you all really need to start working on. Come to class. Okay, this is something that's really, really frustrating because we're spending a ton of time on Zoom and you all aren't showing up, and then you email us like, well, I need help. Well, you've got help every single day that you're supposed to be in class. Go to Zoom, okay? Don't think of it as an option. Just go. It's mandatory. You're supposed to be showing up at Zoom every time you're in class. When you do come to Zoom, we can talk to you individually about kind of your progress and the things that you specifically need to do, but we can also help you with the math. That's what we're here for. We're all degreed mathematicians, okay? And we love teaching it. We love helping you with it. But you need to come kind of prepared. If you come in and just be like, wow, I'm really confused. Okay, what are you confused on? You can't be like, well, everything I've done is confusing. That's not helpful, okay? And then you can't be like, I hate unit 9. It's so confusing. Well, of course it is. If you've not been watching your videos and your worked examples in EdReady, you've got to be really, really specific. So what's really helpful is if you come to class and be like, you know what, I've been working through unit 9. I feel pretty comfortable with simplifying and combining like terms. I feel pretty comfortable solving one-step equations, but when I get to multi-step equations, I really get lost in the process. Can we do a few examples? That's what we want to see, giving us something very specific to help you with. Because if you tell us, well, we're stuck in unit 9, I'm going to start at the beginning and I'm going to start teaching the whole thing. But guess what? Unit 9 would take me a couple of weeks to teach, right? So you really got to come and be specific. Now, another thing, if you're really struggling with a specific question, like you're hung up on this one question and you just can't get past it, don't try to recite it from memory, okay? You could be missing a tiny word in the problem that makes a ton of difference, okay? So what you need to do is if you're struggling with a very specific word, hold tight, I need water. If you're struggling with a very specific problem, I mean, what's really, really helpful for us is one of two things. You can come to Zoom and be ready to share your screen, and then you can have EdReady already pulled up and you can show us the problem you're struggling with. Or even better, if you're working on your EdReady, say you've gotten your kids to bed, you got tons of time on, not tons of time, there's no parent on the planet that has tons of time, but I mean, you've got time on your hands, your kids are settled, you're doing your homework. If you get stuck on a problem and it's 11 o'clock at night, please don't email me. I'm not going to answer your email at 11 o'clock, but take a screenshot of that problem, okay? And well, you could email me, but you're not going to get a response. But go ahead and take a screenshot of the problem you're struggling with. You can go ahead and email it to me and say, hey, I'm going to join Zoom tomorrow. This is a problem I'm having a hard time with. Or you can just have that screenshot ready to go when you actually join Zoom, okay? But if you've got like especially a word problem, you could be missing one word that messes everything up. You could be missing one plus sign that messes everything up, okay? So come to Zoom prepared, come to Zoom often, first of all, but come prepared. Come with specific topics that you're struggling with, okay? And then if you're struggling with very specific questions, bring those questions with you, okay? We can help you. Like I said, we're all teachers. Some of us have been teaching, one of us in particular has been teaching longer than I've even been alive, okay? So we're very experienced teachers. We love what we do. You just got to kind of come prepared and give us stuff to help you with, okay? Hopefully this series of videos is helping. If not, just let us know and we can keep working at it. All right. Good luck and take care.